Okay, and you can see the timer here. Okay, so today we're going to talk again about adding fractions. Now, all a fraction is a division problem, right? So if I take a dollar, or any object actually, if I take one whole of something and I divide it by 2, you see the 1 divided by 2 is 1/2, right? And we know that if we cut something in half, well, we each get half, right? If 2 people divide up one thing, if 3 people decide to divide up one thing, a candy bar, divided by 3 people, each person gets 1/3 because we want equal parts. That's why they're all the same size, right? The 1/3. What happens if 4 people decide to divide something up? One candy bar divided by 4 people. How much do we each get? 1/4. So all a fraction is a division problem. If 12 people divided up a candy bar, we would each get 1/12. Would you rather divide up the candy bar between 2 people or 12 people? 2 people, because you're going to get more, right? So the whole point of a fraction having a denominator, the denominator tells you the size, tells you how many times that thing was cut up. So it's less than a whole. It's always less than a whole, a proper fraction. Now, the whole problem is, though, if I want to add fractions, if I try to add 1/2 plus 1/12, the problem is that they are different sizes. They are different sizes, okay? So I have to be able to make them into the same size. Let's say we were going to add 1/2 plus 1/12. And because this whole page has too many, I'm just going to only take out the 12ths, and here's my halves. And you already noticed that the problem is that they're different sizes, okay? So I have to make them into the same size piece. Well, if I took the half and I cut it up, you know, I could make it smaller, couldn't I? So how would I make it smaller? How many 12ths are equal to 1/2? 6. You counted 6, and then mathematically, what would we have to do to 1/2 in order to make it into 6/12? Multiply it by 6/6, right? Because 6 times 2 is 12, 6 times 1 is 6. Why 6/6? What is 6/6? 1. Does everybody know their 1 times tables by heart? Is that the easiest one? Because what happens when you multiply by 1? Exactly, it doesn't change the value, which is when we say I multiply a fraction by 1, I get what's called an equivalent fraction. What does an equivalent fraction mean? Oh, they're equal. Because if I multiply 1 times 1/2, I still get something that's equal to 1/2. Now, this one is easier because you can see it. Not all fractions. I don't have every single fraction that exists. Okay, oh, actually, sorry. Let's finish the problem before we go on to another one. So if we finish the problem, now if I make 6/12, the same thing as 1/2, these are equivalent fractions, plus 1/12, how many 12ths would I have? 7/12. And you can actually see that. Here's 6/12, which is equal to 1/2, plus an additional 12 would give us 7/12. So the rule when we add fractions, we have to have the same denominator so that the pieces are the same size. And then we just add the numerator. The numerators tell us how many of those pieces do I have, right? So the numerator is like the number, and the 12th, the denominator, is basically, how would you describe the denominator? The denominator is kind of like the size. Remember you were saying they're different sizes. So something that's a 12th means that the original piece, whatever it was divided into 12 equal pieces. So as the denominator gets bigger, what ends up happening to the size of each piece as the denominator gets bigger? The pieces get smaller. And the whole point is that they're different sizes. Okay, let's talk about an example that you had from the homework, because not all fractions are on these little sheets. So is there one that you want to go over from the activity? Which one? F. Okay, let's do F. And F, E. Okay, we can do E and F. That's true. We can. And they're actually the same fractions, but they're different. There's subtraction and addition. So 7/15 plus 2 32s. What I want you to notice right away, oh, 35s, 35s. Thank God it's 35, not 32. That would be way too big. Okay, what I want you to notice right away is a 15th. I don't even have a picture of a 15th, but would it be bigger or smaller than a 12th? Smaller, okay? Now, one strategy we can actually have is we can go back to some of the things we learned. I really like the prime factorization method, okay? So prime factorization. 15. Tell me two numbers that multiply together to give me 15. 5 times 3, or 3 times 5. So 15 is equal to 3 times 5. Let's do 35. Okay, that's okay. We can look it up. 7 times 5. Good. 7 times 5. So one thing you might notice right away is that 5 and 35 have something in common. What do we call that? That number that they have in common is the GCF, the greatest common factor. The greatest common factor of 15 and 35 is 5. Okay, now they also have, so in order to find, that would be the greatest common factor, but we want the lowest common multiple. So we can use that 1, 5 that they have in common, and then we can multiply by 3, because 3 times 5 is 15, right? And we can multiply it by 7, because 7 times 5 is 35. So this number, when I multiply this number out, it's going to contain a 15 and a 35. But it only has to have that 1 5. I don't have to have 2 5s, because if I multiply by another 5, it's going to be way too big. So if I multiply this whole number together, 5 times 3 times 7. Can anyone do that on their calculator right now? 105, okay? So I want to make a common denominator. The common denominator is going to be 105, because 105 contains 15 in it, and it contains 35 inside of it as well. Do you see how I multiplied these numbers together? So 3 times the 3, basically the 5 is the shared number, but 5 times 3 would be the 15, right? 5 times 7 would be the 35. If you also were just to count by multiples, which it would take a while, okay, but if I did multiples of 15, that would be 15. What would be the multiples of 15? 15, 30, uh-huh, 60, wait, yeah, 75, uh-huh, 90, I should just trust you, okay, add 15 more, 105. Look at that, 1, 2, 3, 4, 5, 6, 7. This right here is 15 times 7, right? Okay, now let's list the multiples of 35. Give me the numbers that just count by 35s. It's hard, right? Because we don't know these ones by heart. So 35 times 1 is 35. 35 times 2, if we double it, 70. 35 times 3, 105 is 35 times 3. Do you see that? Okay, so now I want to make common denominators. This is taking a whole page. We're going to make common denominators, we're going to make equivalent fractions. 7 over 15. What do I have to multiply by 15 so that I get the common denominator of 105? 7 over 7. So I'm going to multiply by 1 to make an equivalent fraction, right? Are you with me? 7 times 7 is 49. So all I made was an equivalent fraction. I can always multiply the numerator and denominator by the same number and make an equivalent fraction. Now let's do the other fraction. The other fraction was 2/35. I want to make the denominator 105. What do I have to multiply by in order to make 35 into 105? 3. So I'm going to multiply by 3/3 since that's the same thing as 1. And what's my equivalent fraction? Can anyone tell me? Yes, 6/105. Now imagine you took a candy bar and you cut it into 105 pieces. They would be really, 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 really big or really, 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 really small? Oh, slivers. Okay, you're getting crumbs now. So I get 49 of the 105 crumbs. You get the 6. We add them all together, and how much do we get total? Once they're the same size, we can add them, right? How many do we have all together? 55, 105, right? Does everybody see how we got that answer? 55, 105. Now, is that an acceptable answer? Can we keep that answer? Is that answer just fine? What do we have to do with the answer? Simplify it. Okay, it's looking like I'm going to need another page for that, okay? So I'm going to turn the page and I'm going to take 55, 105. 55 over 105. What number goes into each of these numbers evenly? 5. How do you know that? Yeah, so I can also divide by 5/5. How many times does 5 go into 55? 11. How many times does 5 go into 105? Here, let's do long division. 5 into 105. How many times does 5 go into 10? 2 times. 5 times 2 is 10. Subtract, bring down a 5. How many times does 5 go into 5? Once. So 11/21. Can we reduce 11/21 anymore? We can? What number goes into 11 and 21 evenly? Does 11 go into 21? Oh, 11 goes into 22, so it's close. But since 11 is prime, and since 11 does not go into 21, we can't reduce it any further. Okay? Should we try one more? A, okay, 3/4 plus 1/2. Is this the one? So this is a new problem. So you guys, what would, actually we could even see, this one we could model using our fraction pieces, couldn't we? Are these fourths? How many of them do I need to make 3/4? 3 of them. And are these half? Oh, here's a half. Half plus 3/4. So right away, if you notice, what would be the lowest common denominator between 4 and 2? So we need to find a number that they both divide into. 2 goes into 2. Does 4 divide into 2? Or we could do multiples, right? Multiples of 2. Let's count by 2. 2, 4, 6, 8. Can I list them all? No, I can't. Multiples of 4 are 4. Okay? Which numbers and their multiples do they both have in common? 4. And you can actually see, look, I can make the fourths, I can make a half into fourths, can't I? How many fourths? I need to make this have a fourth, or a denominator of 4, not 1, sorry. How many fourths is 1/2? Right, 2/4. Plus 3/4. 2/4 plus 3/4 is 5/4. What kind of fraction is that? Yeah, because if I have 4/4, I have 1 whole, don't I? So I have 1/4 left over. If I have 5/4, I have 1 whole is 4/4. So this is the same thing as 1 and 1/4 would be the leftovers, yeah? Okay, this one is getting kind of long, so we're going to stop it